Welcome to Dr. P Maths, where we develop our coding skills by solving mathematical problems at GCSE A-level and beyond. Today, I'm going to show you how to solve simultaneous equations. I'll show you mathematically, and then we'll create an algorithm in Python that will do that for any inputs. So let's begin by the maths. So there are two ways to do this: substitution and elimination. So let's focus on the substitution part. So we're going to call it sub because that's what we're going to do. So what I'll probably do is we'll label this equation 1 and we'll label this equation 2. And what I would likely do is rearrange for Q and then substitute in. So we've got P minus Q is equal to a half. And I think Q will be the easy substitution because it's 2P plus Q. So I'm going to say P is equal, and that should be a minus half, it's equal to minus a half plus Q. And then we'll just bring the half over. So we've got P plus a half is equal to Q. And what we'll do, we'll call this equation 2A. And then we will put 2A into 1. So then this will give us, I'll just write it here, we'll say 2P plus, and remember we replace Q with P and a half, P plus a half, and that's equal to 2. And then from there, we can just collect up the numbers. So 2P plus P, that's going to give me 3P. So 3P, and I'll just move the half over. So 3P is equal to 3 over 2. And therefore, our only conclusion is that P must be a half. And then if P is a half, we just substitute into the equation, substitute into any equation really, but given that it's simultaneous equations, it must work in both cases. So if I've got P half and I've got Q, then from there, we can figure out that we can say, well, what must Q be? Well, Q must equal 1. Because then if that's the case, then we've got a half by substituting to 2. So I'll make a label there. Half minus Q equals minus a half. Therefore, the only conclusion is Q must equal 1. And we can confirm that by substituting into the other one. So 2 times a half would be 1. So 1 plus 1 would be 2. So that's the substitution way. Now, let's do the elimination way. So the elimination way, I'll just start over here. So elim here. And what this does is that we want to make one of the coefficients equal, either the P or the Q. And it's probably easier if I make the P coefficients equal. So I'm going to multiply equation 2 by 2. And then that's going to give me 2P minus 2Q equals minus 1. And now I've got a set of two equations. 2P plus Q is equal to 2. And 2P minus 2Q is equal to minus 1. So we'll call this 1 and we'll call this, say, like we did earlier, 2A. So then we're going to do 1 minus 2A. And then 2P minus 2P will be 0. So we're going to have 0. And then Q minus 2Q is going to give me, so minus will be a plus. That's going to give me 3Q is equal to 3. So 2 minus 1 will be 3. Therefore, our only conclusion is Q is equal to 1. And then much like what we did earlier, substitute in, but we'll just do it in reverse. So Q is 1 and P must equal a half. And that is how you solve a simultaneous equation. Pick whatever effort you prefer. What I will say is when you're dealing with a quadratic simultaneous equation, so one equation that's quadratic, the other that's linear, then you would have to do the substitution method. So here is the code to solve a simultaneous equation. And there's quite a lot going on here. And in order to interpret the code, we first need to know a little thing about a theory called matrices. And we're going to use matrices a lot more as time goes on. And certainly when we do the high-level mathematics and high-level coding, matrices will become a regular thing. But for now, we're just going to go through the basics. So if we look at the equation, the simultaneous equations we did earlier, it was this. 2p plus q, 2, and we had p minus q, minus a half. So that was the equation we had. And we had to solve for p and q. Now, one of the things you can do in higher level mathematics, you can put these things in the matrix. And the reason for that is that if you look at this equation, we've got two unknowns and one equation. So we need a second equation to make it work. So we've got two unknowns, two equations. But in theory, we could have, well, infinite equations and infinite unknowns. And certainly when we do high level mathematical modeling, we might have dozens, thousands of equations and thousands of unknowns. So it's very easy for us to solve, say, 2 of these, but could we solve 1,000 of these? Well, the answer is no. That's why you have computers. But in order to do that, we need to represent these as matrices. So how do we do that? So let's look at the coefficients. So this one, the coefficient is 2. This one, the coefficient is 1. So there's always a sneaky 1 when it's on its own. And 1p, and this will be minus 1q. And what we do, we establish a matrix of coefficients. And the reason for that is if you have to look at this equation generally, let's call it, it would be AP. So P being your variable, A being your coefficient, plus BQ is equal to some form of constant. And then similarly, DP plus EQ would equal F. So this is more of a general form of this, where A is your coefficient. So in our case, A is 2, B would be 1, D would be 1, and E would be minus 1, C would be 2, and F would be minus a half. And I was mentioning matrices, what we can do, and I'll carry on over here, is we can write it out like this. So the general form would be AB, DE, and then we would have XY. And then that would equal CF. And the thing about matrices is that this is how you multiply them. A times X, B times Y, and then you would do it in different dots, so DX and EY. And think of it just like doing a expanded to brackets. You just have to follow certain rules. So if we do that, we end up with AX BY is equal to C, and DX EY is equal to F. Now, if we just apply it for our problem, which is just over there, we would get the following matrix. So A was 2, B was 1, D was 1, and B was minus 1. And we get X and Y. Well, we said X and Y. In our case, it's P and Q, so I'll just correct that. So let's say P and Q. And that's going to equal C and F, which we already know to be 2 and minus a half. Now, that has to be in this form in order for us to solve this. So let's now move on to the actual code itself. First of all, we need to import NumPy as MP. Let's talk about that a bit more. So NumPy stands for numerical Python. And what it does, it contains some subroutines or some commands that we need to solve equations. So for example, we need the array, but without importing NumPy, we can't use the array command. We can't use the linear algebra command, which I'll go through in a minute. And import is basically us taking something from there. So for example, let's say if someone has a cake that you like, well, if you take that, you're importing that. But don't be importing people's cakes, please. And this MP basically means rather than us writing NumPy all the time, we write MP because mathematicians and coders, we don't like writing. So rather than us using NumPy all the time, we can say MP. And in theory, we could have called it anything really. So you can see here, we've got MPs here rather than us writing NumPy. So mathematical model, 3 things: input, solve, output. So here is our input. So our input is float x1, y1. We talked about this in the previous one, what float and what that means. But x1 will be our coefficient, which will be 2, y1, so y1 would be 1. Our x2 would equal 1, and our y2 would be minus 1. C is going to be what our equation equals to. So equation 1 is equal to 2. And equation 2 is equal to -1/2. So that's what we'd input in, which we'll do in a minute. Now, the reason why we do it this way is because we want it to be general. We want it to work for any simultaneous equations, for any user inputs. Now, let's talk about the solving. So in order to solve this matrix problem we've got here, we need to create an array. Now, what is an array? At its basic level, an array is a special variable that allows us to hold more than one value at a time. Now, what do I mean by that? So let's take an equation and say x equals 5, and I put that into Python, kind of like I've done over here. Now, that's one variable. Although it's a constant, the principle is still the same because x can vary in theory. I call 7, then that's changed. Now, that's only holding, that's one placeholder for one thing. But we can see here with an array, if we want it to be this matrix I've talked about, we've got 4 things going on here. So we need to create an array in order to hold 4 or more values. And I talked about how with simultaneous equations, I could have, say, 1,000,000 equations, 1,000,000 unknowns. So we need an array to hold all those. So at the moment, we've just got 4, x1, y1, x2, y2. And the NP is basically what I said earlier. It's the command telling us, well, we are using the NumPy database to create an array. And again, without the importing, the computer is not going to know what array means. So we have to always import if we're going to do something like that. So what this does, this creates the matrix. So I'll just do a little arrow to the matrix there. So it creates that matrix. Now, moving on to B. B is NP array CD. So what that does, that creates this matrix here. So it's actually technically a column vector, but it creates this here, so C and D. So we talked about C and D. C is 2, D is -1/2, and then x1, y1, x2, y2 are the coefficients of the other one. Now, this part here is the solver. So linear algebra solve, A and B. So that's basically us trying to find PQ. Now, the reason why we use this command is that linear algebra is basically a different field of mathematics where you're dealing with multiple equations, multiple unknowns. So in our case, like I said, it's quite simple. 2 equations, 2 unknowns. But what if it wasn't? What if it was 100 equations and 100 unknowns? Then we cannot solve that really as humans. So the computer will do that. But in our case, it's quite simple. Like we said, 2 equations, 2 unknowns. So solving the matrix A and B will give us the output of our 2 simultaneous equations answers. So in our case, x was equal to 1/2, or p, whatever the variable was, and q, or y in our case, was equal to 1. So this was our answer. However, it still looks a bit clunky. So what we want to do, we want to separate x and y, and this is where the output phase comes in. So when we've got x equals S0, what that does is that extracts from the first column, which would be here. And then S1 extracts from here. And rather than doing it 1, 2, they start at 0. So 0 extracts it from the first one, 1 from the second one. So then we get our value of x is equal to 1/2 and y is equal to 1. So now I'm going to run this. So x1 is going to equal 2. So that was our first coefficient. y1 is going to equal 1. x2 is going to equal 1 as well. y2 is going to equal -1. The answer for equation 1, so our first answer, was equal to 2. And equation 2 is equal to -0.5. And therefore, we get our answer. We can see it's outputted x equals 0.5 and y is equal to 1. Make sure you rate, comment, and subscribe, and I'll see you on the next one.